Hello everyone, I am De Yutian from Peking University. Today I will introduce my work on detecting user-perceived failure in mobile applications via many user traces. Mobile apps help people do their daily tasks. However, users may encounter failures in mobile apps. Failures in mobile apps will prevent users from progressing in mobile apps and accomplishing their tasks, reducing the quality of user experience and leading to user churn and revenue loss. So it is important for developers to detect failures in mobile apps. Usually, developers will detect anomalies in software logs, and these anomalies probably imply that mobile app failures are occurring. Among all failures that occur in mobile apps, some failures are perceived by the users, whereas the other failures are not. Users may not perceive the existence of failures because of some failures had already been tolerated. Failures that are not perceived by users do not affect the user experience, so developers should focus on fixing the user-perceived failures to alleviate the bad influence of these failures on user experience. User perception of failures can be reflected by user behavior. By analyzing user behavior in mobile apps, we can infer whether a user has perceived failures or not. So in this work, we propose a new approach to detecting the user-perceived failures based on the user traces in mobile apps. We speculate that when a user perceives a failure in a mobile app, the user will backtrack from the mobile app page, revisit the page, and check whether the failure still exists. By detecting such user behavior, we can infer the existence of user-perceived failures. To the best of our knowledge, we propose the first approach to detecting user-perceived failures in mobile apps. Let me formalize the input and the output of our approach. Before applying our approach, developers need to select a task in the mobile app. Then the developers should collect a set of user traces with regards to the selected task, together with a set of mobile app pages that are related to the task, the beginning page of the task, and the end page of the task. Here, a user trace refers to a sequence of page navigation events of the user in the mobile app. Each page navigation event contains a user ID, a page ID, and a timestamp. Page parameters, which usually contain sensitive information of the pages that user navigates to, are not included in the user traces in favor of user's privacy. The output of our approach is the detection results of whether a user has perceived failures. If our approach predicts that a user has perceived a failure, our approach will also locate the page where the failure probably occurs. The main idea of our approach is that a user may backtrack and revisit a page several times intensively if she perceives a failure on the page. Our approach has two steps: model generation and anomaly detection. In the first step, our approach generates a Markov model to reflect the user behavior. In the model, the nodes represent the mobile app pages and the edges represent the page transitions. With the help of the model, our approach can distinguish whether it is normal to backtrack from a mobile app page. In the second step, our approach detects user-perceived failures based on the model. Our approach counts how many times that a user backtracks on each task-related page in total and intensively. Then, our approach computes an anomaly score for each user based on the number of times that she backtracks from each task-related page, and predicts that a failure occurs if the anomaly score is greater than a threshold epsilon. We evaluate our approach in a dataset of user traces collected from a real-world mobile app. There are 5,183 user traces in the dataset, where 1,619 users perceive failures. The results show that our approach can achieve 74% precision and 75% recall, which implies it is feasible to detect the user-perceived failures with only front-end user traces. We plan to improve the effectiveness of our approach, as well as evaluate our approach in more datasets in the future. That's all, and thank you for your attention.